Okay, let's start this section off with a video, and I muted it because YouTube has been really annoying with this audio detection and copyright, but I'm just going to show you this without the audio. Now here he's eating a spaghetti noodle, and watch. That's not it. Watch. Notice it's going back. Okay, that's enough of that. Yeah, you don't need to see the rest. And yeah, sorry for the poor quality, but yeah, this is probably how many decades ago, so that's why it looks like that. But how does he do this? Like, he's eating it, and then it came out his nose, and now he's out the other nostril. Well, it deals with the anatomy of your oral cavity and the nasal cavity. Okay, so let's talk about ingestion. So ingestion is the first step of digesting your food because now you're taking food and introducing it to your GI tract. And where does it enter? It enters through the mouth. Now, the oral cavity is sometimes used synonymous with the mouth, and it's just referring to this entire structure overall before you reach the pharynx. Now, what else do you find in the mouth? You find the tongue, you find salivary glands, and you also find teeth, right? But what the oral cavity, again, that very first step, important step, so it's going to perform both mechanical and chemical digestion. Okay, so here's an overview of the anatomy of the oral cavity, and I'm going to explain what I think, how that guy was able to do that trick. So what did he do? He took that noodle, and now it's going into his oral cavity and now into his pharynx. But what I think he did is notice that during the video he kind of held his nostril, one nostril, and then you notice he kind of like did this motion. What I think he was doing was compressing his lungs to increase the pressure, and that pressure, again, remember that pressure is moved from high to low pressure. So if he's building up pressure in his lungs and doing a little puff of air, that's going to bring the noodle along with it. So that noodle is going to flip out through that open nostril, because again, that's why he closed one nostril, or that's why I think he closed one. So now he has it in one nostril. What can he do? He can swallow the other one, and you know, say he does a like puff of air again, and go make it shoot out his other nostril as well. So that's what I think is going on there. I don't know, speak the language in the original video, so that's my guess. But what I'm showing you here is that yes, your nasal cavity and oral cavity are connected at the pharynx. Okay, and here we have a picture of the mouth as seen. Like pretend this you're a potato chip or a nugget, and then you bring it toward your mouth. Well, you're seeing it from the first perspective of that potato chip as it's entering your mouth as you ingest it. And what we see is like, okay, all these structures, especially a lot of teeth. And speaking of teeth, and hey, what is this guy doing all by himself on the couch? He is in the process of mastication. And what is mastication? Well, it's the physiological term for chewing. Yeah, so that's like a lot of things in physiology. Why can't we just call it that? They have to come up with a more technical term. Well, that's the term for chewing. But what is chewing? What is mastication? You're just taking food that you ingest and then grinding and crushing it over and over, doing that mechanical digestion to break it into smaller parts. Now, what are the muscles of mastication? We did cover this in AMP1, but these are going to take your lower jaw and also help to apply pressure and bring it up toward your mandible to crush all the food between your teeth over here. So there are four primary muscles of mastication: temporalis masseter and the lateral and medial pterygoid. And what else helps with mechanical digestion in the oral cavity? Well, you also have this big old muscle called the tongue. Yeah, the tongue doesn't look like a typical muscle, it's its own special thing, but it is a very muscular structure and you can move it around in your oral cavity. So it helps to move like food toward your teeth. It also helps to kind of also mash food as well. So it applies pressure and shifts food around to where it can be mechanically digested. It also helps with mixing the saliva in your mouth with your chewed up food as well. So speaking of liquid, we also have our salivary glands. And there are three pairs of salivary glands, so here we're seeing only the left of each pair. But what are the three salivary glands? We have the parotid salivary gland, and this is the duct leading from the parotid duct leading from the gland, so it's going to dump its saliva into the oral cavity. Now over here we have the sublingual salivary glands. So sublingual is a very useful term. So lingual is like Duolingo, my favorite tech website, right? So lingual refers to the tongue. So sub means below the tongue. So this is a salivary gland below the tongue, and then it's going to secrete saliva into through these little tiny ducts. And if you lift up your tongue, you look at someone and they lift up their tongue, you might be able to see some of these small ducts if they salivate. Or like, to use a schoolyard term, like, I know there was like someone in the schoolyard who could like somehow constrict like the muscles of their throat and their tongue to actually squirt out saliva, like some of those frogs that squirt out things. I think they called it gleeking or something like that. But yeah, when it can squirt, that's where it's coming from, these salivary glands. We also have the submandibular salivary glands, so mandible referring to what commonly called the jawbone. But this duct is going to lead over here. So again, this is like our three pairs of salivary glands: parotid, sublingual, and submandibular. Now, talked about salivary glands. What is saliva? So saliva, well, we produce about a liter or a liter and a half of saliva each day. And you probably guessed that most of your saliva is water, and you're correct. Yeah, around 98 to 99.5 of it is water. Now, why do you have so much water? Well, one thing is that your saliva, all the fluids will help to dissolve things like salts and sugars and things that are soluble in water to convert them to solid to a liquid form. And the thing is that having a lot of fluid also helps to distribute the enzymes that you need to chemically digest and break down your food when it's in your oral cavity. So examples of these enzymes I definitely want you to know are salivary amylase, and amylase is a type of carbohydrate, and it sounds like amylose, right? So that's the type of carbohydrate it helps to specializes in breaking down that linear chain of carbohydrates. And there's also something called lingual lipase. So lingual referring to the tongue, and then lipase referring to lipids. So this is something the enzyme produced by glands near the tongue that's going to help to break down lipids. But is saliva just water and enzymes? Well, you also have things like mucin glycoproteins that help to thicken up your saliva. So yeah, most of your saliva is water, but your saliva can be thick, so these help to do that as well. So the OpenStax book says that the normal pH range for saliva is around 6.35 to 6.85, but it depends on the book. But what you should appreciate is that it has a range. And then the thing is that your saliva also has buffers that help to neutralize acids. Like, there are a few basic foods out there, I'm blanking on them right now, but there are a lot of acidic foods, like something that has vinegar or a lot of citric acid. Like, say you're drinking lemonade or lemon juice, and that's like a pH of like maybe around 3-ish. So compared to a pH of 3, so again, remember that the lower the pH, the more acidic something is. Relative to acidic foods, saliva is basic, or more out toward the alkaline side. Even though it's not as alkaline as water, even though it's not neutral like water or alkaline past that point, it's still relatively alkaline compared to a lot of the food we eat. And in other sources, I've also seen the pH range from 6.2 to actually toward the alkaline side. So this bicarbonate, especially this bicarbonate ions, these help to push saliva toward the alkaline and basic side. Now, you also find things like antimicrobial enzymes. Remember that the first point of entry of your food to your inside environment is through the mouth, but that can also be the point of entry for a lot of pathogens as well. So it makes sense to have a lot of enzymes that help to neutralize any potential pathogens that can cause diseases. So find things like immunoglobulins, aka antibodies. You also find all these enzymes that help to dissolve or impede or kill bacteria and other microbes and prevent them from hitching a ride with your food and causing disease further on as the food travels throughout your body. And then, but what I'm getting at here is that saliva composition is variable. Like, say you're getting anxious and you're about to do a speech in front of the whole class, well, what happens to your mouth? Well, remember that whole sympathetic nervous system and how you can have that dry and sticky mouth. Hey, the stickiness comes from these mucin glycoproteins, right? So if you have less water, now you're going to have like stickier mucus, and you're going to have stickier mouth and that dry mouth. And the thing is that, yeah, with this huge pH range, you notice that the pH of your saliva, and that's why there's not just one single number for this, is that so your saliva can change its composition, or your body can change its composition of saliva depending on the situation and what it needs to maintain balance in your body overall. So let's put this together. So mechanical and physical digestion in the oral cavity. You have things like the teeth. We're going to cover that more in detail in another section. But we also have like the tongue as well. So we have the teeth and the tongue. So it's kind of like chopping. The analogy is like, okay, when you're making poi, what do? You take the kalo, you take the taro root, and then you chop it up and you mash it together. So this is the mechanical digestion. You're taking the initial food stuff and you're breaking it down into smaller pieces. Mechanical digestion works together with chemical digestion. And to extend my analogy further, it's kind of like cooking your taro roots, cooking your kalo, right? So when you're cooking, you're kind of chemically converting things. Well, in terms of chemical digestion, you're chemically converting things so that they're more easily digested by your system. Now, what happens when you combine mechanical digestion with chemical digestion in your oral cavity? Eventually, you'll get something called a bolus. And so what is a bolus? It's just that mashed up mixture of food and saliva, so that semi-solid paste. So this is why I use that poi analogy. You're taking mechanical digestion, you're converting chemically, and you're making a paste. And that's what we have with the bolus of mashed food that combined with your saliva and through mechanical and chemical digestion. And that final product is a bolus. Alright, so what did you learn from this lecture? You learned to identify different structures of the oral cavity. We'll cover teeth more in detail in another lecture. And then we also can define mastication. Mastication, just a fancy name for chewing, right? We also talked about salivary glands and the 3 pairs of salivary glands and their general location and where their ducts lead to into the oral cavity. And we also talked briefly about saliva, which is a complex mixture, but we talked about important components and how they help with digestion, but also our immune defenses as well.